All right, let's get right into it. For years in the AI world, we've all been obsessed with one thing: speed. More power, more speed. But what if I told you that entire era is, well, it's over? Today, we're going to unpack a pretty wild story: how the top AI chip from just a couple of years ago is already a museum piece. And it's all because the very definition of power has changed. It's not about speed anymore. It's about efficiency.
I mean, think about that for a second. How does the best of the best, the absolute pinnacle of technology, become legacy in just 2 years? It sounds insane, right? Well, the answer isn't just about a new chip being a little bit faster. No, this points to a massive, fundamental shift in the entire economics of AI. The rulebook is literally being rewritten as we speak.
Okay, so Section 1, the end of an era. And to really get what's going on, we have to go back to a single, pretty shocking decision, a move that basically sent a tremor through the whole tech industry and screamed, the party's over for the old way of doing things.
So picture this: it's early 2026 and NVIDIA does something, well, kind of unthinkable. They just stop. They pull the plug on their flagship H200 chip. We're talking about their crown jewel. And they take all that precious, hard-to-get manufacturing capacity at TSMC and point it at something completely new. This wasn't just your standard upgrade. This was a hard pivot, a complete change of direction.
And you don't have to guess why. The reason came straight from the top, from NVIDIA's own CFO, Colette Kress. And it was just brutally honest. She said, continuing large-scale mass production is no longer commercially meaningful. Wow. I mean, let that sink in. This wasn't a quiet retirement for the chip. This was a strategic takedown. The market was moving so fast that making what was, just yesterday, the best chip in the world didn't make business sense anymore. So what on earth could have changed that quickly?
All right, Section 2, let's meet the new bottleneck. Because you see, the reason for this crazy pivot wasn't that they suddenly invented a magically better chip. Nope. The answer lies in a brand new problem, a massive bottleneck that the entire industry suddenly slammed into.
And here it is. This is the heart of the whole issue. For years, the big, expensive problem in AI was training these gigantic models. Spending months and millions of dollars teaching them how to work. But that's not the main game anymore. The real challenge now is running them, what we call inference. And the demand for inference isn't just growing, it's exploding exponentially. Think of it like this. Training is like building a factory. Inference is running that factory 24/7, churning out products for millions of customers. That's where the real demand is now.
So what's driving this explosion? It's a new kind of AI, something we call agentic AI. We're moving way beyond just asking a chatbot a question and getting an answer. These new systems, they're different. They can handle complex, multi-step jobs. It's like having an AI that doesn't just answer one question, but has a continuous thought process to solve a bigger problem. And to do that, you need an absolutely colossal amount of inference power, and it has to be super, super cheap.
And that insane, insatiable demand for inference has created a huge problem. We're talking about a full-blown supply chain crisis for one tiny but absolutely critical component: high bandwidth memory, or HBM. Every new AI chip is hungry for more and more of this stuff, and the simple truth is, the world just cannot physically make it fast enough. We've hit a wall.
And here's why. Making the next generation of this memory, HBM4, is just wildly inefficient. The best way to think about it is this. For every one wafer of this new HBM4 that a factory makes, they have to give up the ability to make 3 wafers of regular memory. That's a 1-to-3 penalty. You're sacrificing a huge amount of your manufacturing capacity just to make this one specialized part. And that creates a bottleneck you just can't brute force your way through. No amount of raw processing power in a GPU can solve a physical supply crisis like this. So, okay, the industry hits this memory wall. What do? Well, this crisis forced a total reset, a complete rethink of how AI hardware should be built. The goal wasn't just make it faster anymore. The new goal was to design a system that could be smart, that could intelligently work around this memory bottleneck. And that brings us to NVIDIA's answer, the Rubin platform.
And look, on the surface, the headline number is just staggering. 50 petaflops. The new Rubin R100 GPU delivers 50 petaflops of performance specifically for these inference tasks. To give you some context, 1 petaflop is 1,000 trillion calculations every second. So yeah, it's a ridiculous leap in speed. But, and this is the crucial part, that's not the most important number on the slide. No, this is the number that changes everything. 1/10 the cost. It delivers all that mind-bending performance at 1/10 of the cost for every million bits of information, every token it generates. It's not just about being faster, it's about being fundamentally, radically cheaper to create intelligence. That is how you get around a supply bottleneck. You make every piece you can get unbelievably efficient.
And when you actually put the two generations side by side, Blackwell versus Rubin, the new strategy just pops right out at you. Yeah, sure, the transistor count is up from 208 billion to 336 billion. That's expected. But look at where the real effort went. The inference performance? More than doubled, from 20 to 50 petaflops. And the memory bandwidth? Almost tripled, from 8 terabytes a second to 22. Every single one of these design choices is screaming the same thing. We need to feed this beast data more efficiently to slash the cost of every single answer it spits out.
Okay, so Section 4, the rack is the computer. You might be wondering, how in the world did they pull off this kind of leap in efficiency? Well, it's because they completely changed their philosophy. They stopped thinking about just the chip and started thinking about the entire system. You know, the old way of doing things was to build a bunch of discrete separate components. A GPU here, a CPU there, some networking over there. It was like having a bunch of amazing solo musicians all playing their own thing. But the new model, it treats the entire data center rack as a single unified computer. It's not a collection of soloists anymore, it's a perfectly tuned orchestra where every single piece works in harmony to eliminate any delay or bottleneck between them.
And this philosophy has a name. They call it extreme co-design. And honestly, that's the secret sauce here. It's the idea that you architect the GPUs, the CPUs, the networking, even the software, all at the same time as one single integrated system. Because when you do that, you're not just fixing tiny inefficiencies on one chip, you're killing massive bottlenecks at the entire system level.
And this is what that orchestra looks like in practice. The Vera Rubin platform, it's not just one new GPU. It's an entire family of breakthrough chips that were born to work together. You've got the Rubin GPU as the main engine, doing the heavy lifting. Then there's the Vera CPU, which is like the conductor, orchestrating all the data. And then you have a whole suite of new networking gear. The NVLink 6, the Connect 9, the Bluefield 4, the Spectrum 6. All designed with one purpose, to move data between all the other parts so fast it's like it's not even moving. The whole thing is designed from the ground up to be one single, seamless supercomputer.
Okay, let's land the plane here. Section 5, efficiency is the new power. We've seen this massive bottleneck and this radical new system designed to solve it. So what does this all mean? How should we really think about power in this new era of AI?
Well, for starters, the old metrics are dead. Raw speed, all those flops and petaflops. Honestly, it's becoming a vanity metric. It's not what matters anymore. The new gold standard, the only metric that anyone really cares about, is AI factory throughput. It's a simple question. For every watt of electricity you burn and every dollar you spend, how much actual intelligence, how many tokens do you get out at the other end? And when you measure it that way, the result is just breathtaking. For the exact same power budget, the same number of megawatts, the new Vera Rubin system delivers up to 10 times more throughput. 10 times more actual work done compared to the Blackwell system right before it. That's not a small step up. That is a complete paradigm shift in the entire economic model of artificial intelligence.
So this is the new paradigm. We've hit the inflection point. The most powerful AI system is no longer the fastest one. It's the one that delivers the most intelligence per watt and per dollar. In this new world of massive agentic AI, raw speed is legacy. The real power is efficiency, looked at across the entire system. And that's why 2024's top chip had to be retired. It made way for a smarter system, one built for a completely new reality.
And that really leaves us with one final question to chew on, doesn't it? As we enter this new era of hyper-efficient AI factories, we know that solving one huge bottleneck just tends to reveal the next one down the line. So if efficiency is the new power, what becomes the next big problem? What's the next great challenge we're all going to have to engineer our way around?